Yep. All right. All right. So we did a paper on virtual machines, right? All right. So we kind of have a couple of different flavors of virtual machines. So kind of tell me your perceived difference between something like the Java virtual machine and let's say VMware virtualizing Windows. What are those? What's the difference in those tools? Go ahead.
Kind of got that Java is more of a tool to run Java code, so you can run applications that are written in Java on any operating system.
Okay.
And then like VMware just seems to be a general, if you want to have two operating systems on a computer, or like computer programmers can write Windows and Mac software on one computer.
Okay.
It's just kind of basic, just a habit.
Okay. Now, why would somebody? So you started kind of talking about this. So the question would be, why would somebody, if you're a Mac user, why would you virtualize Windows on your computer as opposed to dual boot into Windows? What's the difference between running Microsoft Windows as an application through VMware or Parallels versus having Windows installed on your Mac on a separate partition and restarting the computer so you're natively running Windows? What's the pros and cons of each of those? Go ahead.
Wouldn't the application, in fact, you almost divvy up the system resources that you can have? Whereas if you ran it as you booted up Windows, you probably get all the RAM, maybe hard drive.
Yeah, absolutely. So what's the downside of divvying up your system resources?
Less performance speed.
Okay. Now, I mean, if you have a lot of system resources, so let's say you have 16 gigs of RAM in your machine. You divide that in half. It doesn't always have to be half, but half is an easy number to work with. So you give 8 gigs to the Mac, 8 gigs to Windows. You're still fine, right? You're going to be able to operate on 8 gigabytes. So the RAM is probably less of the issue today because RAM is so inexpensive. But especially when it comes to laptops, for instance, how many of you only have a laptop and no desktop computer? I mean, that's more and more common today, right? Maybe among young people who play video games on PCs, the existence of the desktop is for gaming, where the laptop is basically for everything else. But it is becoming more and more common. Now, would you say that your laptop is less powerful than your desktop? That's less so today than it would have been, let's say, 5 or 10 years ago. Laptops are surprisingly comparable to desktops today. But if you're trying to max out a laptop versus max out a desktop, you're going to do more with the desktop, right? So it's less about the average and more about if you're building a gaming PC, you have some flexibility for your high end on a desktop where you can go and spend a lot of money on like a Alienware gaming laptop or something, and it's going to be really good for a laptop, but not really at that desktop level. So when you think about that, your processor inside of your desktop computer, your laptop, but laptop specifically is kind of the point of that question is most of us are using laptops for our productivity, right? So a good laptop today has a quad-core processor in it. Your average laptop has a dual-core processor in it. So if you divide that dual-core in half and you're giving 1 core to Windows and 1 core to the Mac, you're giving up significant performance doing that. Similarly, the hard drive, 2 different operating systems both competing for the hard drive is a substantial performance hit. Okay, so these are things we talk about more in the computer architecture class, but the idea is that to virtualize an operating system, you would usually do that out of convenience to run, let's say, a simple application. I don't remember if I mentioned it last class or not, but kind of a really common use for it would be for web programmers who give very, very little of their system resources to the virtual machine, but mostly so that they can test something on Internet Explorer, or I guess it's called Microsoft Edge now, whatever. Because even though that's not the most popular browser anymore, it's still a common browser. So when you're writing web stuff, you have to test for all these different web browsers because your page won't necessarily look the same on all of them mostly because anybody know why that is? I'll tell you why in a second. But anybody know why when you create a web page, it doesn't look the same on all web browsers? How many of you have heard that before, or have experienced that before, where you go to a website and it basically is non-functional? I actually think our book in here, I think we had a student in here who was having problems with the Zybook on Microsoft Edge. Like half of it worked and half of it didn't. So most of us have experienced something along those lines where some site just isn't quite right on a certain browser. And then what does somebody say? It's like, oh, well, did you try Chrome? And if it's not Chrome, it's Firefox. Those are kind of our two competitors. How many of you are Chrome users in here? Firefox? Okay. And then a couple of Mac people are going to be Safari. Yeah, Safari's not crap. It's like the distant third. Actually, it's based on WebKit, which is what Chrome was based on initially. But so Safari is a pretty huge step up from Edge. So if you're talking about pecking order.
For the touchscreen, I prefer Edge to everything else.
It's
tailored to that.
And that's fine. Yeah. So I mostly what I'm talking about is compatibility. Yeah, Edge gives you a lot of compatibility issues with some websites. I think pretty clearly it's the most compatibility issues of all the browsers. Probably your best experience is going to be Chrome or Firefox. I don't notice a lot of stuff with Safari, but I notice more with Safari than the other ones.
Internet Explorer?
Well, Internet Explorer and Edge they're the same. They got rid of Internet Explorer and now they have the more integrated Edge. It's the same engine behind the scenes, or at least the same mindset. So why is that? Why is it that the web pages are different on different browsers? What do you suspect that's from? It's actually a software discussion, so very appropriate for us in here. Just luck of the draw. So now, all those browsers we just mentioned, Chrome, Firefox, Edge, Safari, these are all software applications that somebody wrote to solve what we're calling the equivalent problem, right? Show web pages. Make sense? Okay, so what does a web browser actually do? If you had to kind of, and this would be something you probably learned in your 150 or 175, probably 150, but what does a web browser actually do? What does that program solve? What problem is it solving? Go ahead. Okay, so specifically it reads HTML data, right? And we can say it gets a little more complex than that, but let's just keep it simple. So it takes HTML, which is like a tag-based text language that human beings could look at for 5 minutes, but it's not something we have a easy time visualizing. And it turns that into pretty pictures and text, as a simple example. All right. So we might say, well, how hard is that? I mean, shouldn't every browser be able to do that at the same level? I mean, isn't HTML a standard? Yeah, I mean, there's a standard HTML, and now we have the newest standard, HTML5. So shouldn't every single browser know that these lines in HTML5 translate into these pretty pictures and text? So why don't they? I mean, we're going to say that all four of those browsers are written by smart people, right? Professional software engineers from Apple or Google or Firefox group is what came out of Netscape, which is an older browser. I mean, not idiots, right? Okay, this isn't somebody just sitting in their basement saying, "Oh, I'm going to make a browser." Okay, these are real, professional software developers. Yet they have products that solve what seems to be a standard problem differently sometimes. What's that attributed to, do you think? How many of you are console video game players? PlayStation, Xbox, something like that. So, how many of you have gotten a system that was backwards compatible with the system before? Yeah, it's happened before, right? And for the most part, most of the games work fine on it. But every now and then you'll get something that's kind of quirky. Kind of know what I'm saying? Game doesn't quite work right, or sometimes it's some low budget game. That exists a lot more today, like indie games, right? That didn't even exist back in the Nintendo days, but old Nintendo days, like Nintendo, the original. But sometimes there's just some incompatibility issues. Now, if you wrote a website 10 years ago, let's say, would you have the expectation that people could still visit that website today and it should show up? You'd have that if you were a business owner that paid $5,000 for an information website 10 years ago and you put it on the internet, you would expect people could still see that site today. It might not have all the newest gadgets and flashing things and sports scores and all sorts of extra stuff that's common to us today, but you would expect it to still work. Somebody should be able to still go to the website and find your phone number, your email, and you expect that to work. So our browsers today are backwards compatible with the historical HTML. That includes all the way back to the beginning of the internet when things were really bad. And when I say really bad, using structured HTML, correctly written HTML, was more of a recommendation rather than a rule. So in the early days of HTML, and actually we're going to demonize Microsoft in here because I think they do deserve it. Usually I think Microsoft gets unfairly demonized for different things, but Microsoft had a product a long time ago called Front Page. And Front Page was a software tool that allowed people to create web pages visually. So effectively you were like creating a Microsoft Word document, dropping your pictures where you wanted them and stuff like that, and it would save as an HTML page. And Front Page would automatically generate the correct HTML behind the scenes for that page to look right. Well, Front Page created imprecise. It created a good excuse, right? Long line. Is there a long line at Starbucks?
Yeah. I'm not that skilled, but it's long line.
What's up?
It's really long.
Well, hopefully you got it right.
Yeah. It's probably.
I'm just teasing you. All right, so in any case, they had to make them backwards compatible. So Front Page created HTML that wasn't necessarily well-written HTML. And for the time period, it worked pretty well in Internet Explorer. Microsoft controlled both sides. So they were really testing their output on Internet Explorer. But what they wrote, what Front Page created, wasn't correctly formed HTML. Now, Microsoft is still a big company today, right? Important company. Majority of us use Microsoft's operating systems, even us Mac users. We have Windows on our machines because sometimes you have to use Windows software, right? But most of us have Windows anyways because the more software runs on it. So we're very reliant on Microsoft. And especially back then, even until just a couple of years ago, Internet Explorer, even though among technical people, Internet Explorer was considered a unpopular browser, right? How many of you, besides touchscreen here, use Internet Explorer as your primary browser? Okay, and I assume you don't anymore now, right?
I use Edge most.
Okay, but not for your book. Give enough of that. Okay, so now, why don't you use it? As technology people, why don't you use Internet Explorer? What's the advantage of the other browsers? It's just cooler to use Chrome.
Faster.
Faster? Okay.
Like other.
Okay, fair enough. So faster in some situations.
But it's probably the security on a website and Chrome because Chrome is like they can give you anything to access to different websites. But Internet Explorer is for myself it stop you when the website has something different code.
Okay, so you feel like you're more secure with Internet Explorer because it's more picky about stuff, and maybe that comes from the Chrome kind of accepting all those plugins.
Yeah.
So part of its nature of being open to plugins also opens itself up to some other things. Okay, fair enough. But for a long time, let's say Grandpa got a computer. Where does the internet live? It lives behind the blue E. That's where the internet lives, is behind the blue E. All right, so he double clicks on the blue E because every computer came with it. Well, so in any case, the other browsers had to make their browsers compatible with the stuff. And this isn't just FrontPage's fault. That's just an example, one of the things that was putting out a lot of bad HTML on the internet. So over the years, your competing browsers had to make sure that they could show pages reasonably that were not well-formed HTML. Kind of close. Shorthand HTML, that kind of stuff. Not well-formed. So what we have today is this system that's backwards compatible with old school HTML, which means that there are some decisions that have to be made based on, here's some poorly written HTML, what should I do with this? That makes sense? So some of those decisions historically have translated into some minor differences, and some of those minor differences might be annoying major differences depending on the site in terms of how things actually lay out on the screen. Now maybe some of you have bumped into a setting on your browser. It's off by default, at least right now, but there's usually a box where you can say, make my browser Xhtml compliant. Maybe you've seen that before. Or only accept Xhtml. So let's look at this here real quick. Maybe you've heard of XML. All of us should have at least heard of XML, right? Okay, what is XML? This falls into that category of we have a lot of buzzwords, and some of them, a lot of them mean easy things, but
Is it like a page format?
okay, some sort of format. All right.
It's a web format. It looks like XML.
Yes, that's true. So we're going to say XML is based on HTML. So it's kind of a tag-based language. So it's open tag, stuff, close tag, where open tag might be first name, Mike, slash first name. That closes that information. So it's a way for us to mark up data. So if we had a tag like this, if we had first name, just call it F name, Mike, F name, we are giving semantic meaning to Mike by wrapping it in F name tags. This says that whatever's between these two tags is a first name, and its data is Mike. Make sense? So this is a standardized way for sending things, and this is based on HTML. So HTML has a language that's a tag-based language like this. That's for formatting web pages. We have body and head and title and paragraphs and headers and tables, and so we have like a subset of tags for doing web-y stuff. Well, XML, even though this is more kind of a chicken or the egg issue, XML was built with HTML as a model. So we're like, oh, well, this tag-based idea is a good idea. Can we apply it to other problems? Not just the problem of making web pages look pretty, but maybe the problem of having this software talk to this software. Maybe a dental office's billing software talking to their bill processing place to send patient information across between the two, and being able to give semantic meaning to that patient information. So Xhtml is XML compliant HTML, which effectively means correctly written HTML. All right, so if you put your browser into Xhtml mode, then sites that are not Xhtml compliant, i.e. sites that have not written proper HTML, will break. Your browser, it won't look right. Your browser will be picky. It won't rely on all of the backwards compatibility engines that it has for making most web pages somehow look okay. Instead, it'll say, yeah, you either write it right or we're not showing it. That make sense? And eventually, we might work to the point where that checkbox becomes checked by default. Because wouldn't you agree that every single year, let's say, we maybe have less and less of a need for the really old web pages to continue to work? And do you suspect that new web pages that are created today are likely written using proper HTML? Or at least substantially closer to proper HTML. Many web development shops today write all of their HTML testing on XHTML compliance so that they know it's correctly written. And if it doesn't work on XHTML compliant, they're going to keep working on it until it's fixed. They don't rely on that 3 different looks from different browsers, and if you're Internet Explorer, make it do this. If it's Firefox, make it do this, and so on and so forth. All right, so this comes down to software. So when we talk about those 4 different browsers, and to put it in context of this course, we're writing software to solve a problem. And the idea is we would say that Internet Explorer and Safari and Chrome and Firefox, they all solve the problem of being a web browser, right? But they don't necessarily all solve the problem the same. Now, is that okay? Is it okay that they all solve that problem but not equally the same? When we've all kind of picked a favorite. Whether it's we like Google, or we like the name Chrome, or it was convenient, or well, this is just what I always used, whatever the reason is, we have kind of our favorites. Would this fly in real life? If you were having heart surgery and there was a certain instrument that they used for it, and there was 4 different places that made that instrument, and some of them were a little buggy under certain circumstances, our willingness to accept that would go way down, right? So certain things, absolute precision are most important, correct? Now, how many of you have a car? Okay, many of us have cars. Okay, do you suspect that all of us have the same car? Or is there a pretty high chance that in this classroom we represent many different vehicles? Okay, are they all solving the problem of getting you from one place to another faster than you can run? All right, but each car has a different level of bells and whistles and stuff like that. They all solve the problem, and we pick our cars based on our desires, right? So when you're picking a car, what's important to you? So when any of you, when you're shopping for a car, what's a priority for you? It runs. That's a priority for all of us. All right, so that's a common goal for all of us, that if we're going to have a car, we don't want it to be a gigantic driveway paperweight. All right, go ahead. Fitting it. Okay, I'm with you on that. Okay, I don't care about gas mileage. Okay, I care about reliability, but I have to fit in it. Okay, so like my wife drives a Honda Fit. Now, you know what? After you're in the Honda Fit, it's actually quite roomy, but I have to put it on like a shirt. Okay, I crawl in head first, and then just kind of. So I put on the car rather than get into the car. But once you're in, it's pretty roomy. But yeah, so for me, I want to fit in the car. Okay. Some of you, it might be, especially if you commute, if you drive from a far distance, it might be gas mileage, right? It's like, hey, I don't care if it's a little bit too small or not quite, the perfect everything else, but this thing gets 90 miles to the gallon. I only have to fill up my tank, once every other month or something like that. So sometimes that's a priority. So these things have different features, and we choose that, but we all can agree that each one of those vehicles acceptably solves the problem of getting us from one place to another faster than we can run. Okay, so Software is similar. When we're solving a problem, we have to first understand the problem. So this goes back to your 150 stuff, right? So when you're solving a problem, you got to understand the problem. Then you kind of create your requirements, create your algorithm for it, your recipe. So here's the problem I'm solving. Here's my solution to that problem. And as we've kind of seen here, our solution, an individual solution, might not be the same as somebody else's individual solution. Okay? So most of us in here have probably made a peanut butter and jelly before. Do you suspect that we all make peanut butter and jellies the exact same way? Okay, the current trend, as I understand it, is to put peanut butter on both pieces of bread and then the jelly on top of that so that the jelly doesn't go through the bread or something. That's what the cool kids are doing currently. All right, but now they have the bottles. Well, they had those for a while. They had the peanut butter and the jelly in it. You just squeeze it all over and you're done. Right? Smash the bread together. That's a sandwich. It's all going to the same place anyways, right? Okay, so there's more than one way to make a peanut butter and jelly. Go ahead.
I've also seen you do a peanut butter on the edge of the bread with jelly in the middle, so you bite down because it glues on the sides.
But is there still peanut butter in the middle? So then you're missing peanut butter in the inner portion of the bite.
Which kind of just like take it like a pie.
It's a jelly pie with peanut butter edges. So you're saying you still have the peanut butter and jelly taste, but it doesn't have peanut butter throughout.
Right, but you have to bite it right so you get both.
Yeah, I don't consider that acceptable.
Alright.
It falls into a similar category to it's like turkey bacon is not a food.
It's not.
They shouldn't be serving that to people.
You enjoy your jelly on your shirts.
Who cares? You get jelly on your shirt, that's a snack for later. And that's why I wear a purple shirt. This is a peanut butter and jelly day. All right, so the solutions to problems are not as precise as we might assume. All right, but we're still solving a problem, and that problem is going to have rules associated with it. And every now and then, you look at cars or something like that, they get recalled. Sometimes it's recalled for something serious, right? More times than not, it's something little, right? A vent, the little handle on a vent breaks off or something. So something annoying, but people aren't going to die from it. Have you been following this Galaxy Note 7 story? Any of you have a Galaxy Note 7?
The
I
batteries.
mean, these batteries are exploding and catching fire. Yeah, I mean, it's like serious. Go ahead.
At work, they have to like put them in a separate room on a shelf and everything.
Yeah. So if you're not following the story, so Samsung just came out with their new Note, the 5.7 inch, their iPhone 7 Plus competitor, although the Galaxy Note predated the iPhone's bigger screens. But this is great for Apple. Samsung has just taken a hit. They've lost like $25 billion in market share in market capital in the last week from this. So they sold this phone. It's like their flagship product, and it's literally exploding in people's hands. Like people getting rushed to the hospital with third-degree burns. A car, like somebody left it charging in their car, and their car lit on fire. Total loss. Car gone. I mean, like, serious. Airplanes make you power it down. Like, if you take it on a plane until you can't charge it. Samsung says turn your phone off and bring it in for it's not playing out well for them. So it's a.
Wouldn't this be a good time to buy Samsung stuff?
If you believe it's going to bounce back, I mean, it's reasonably speaking, the answer is probably yes. But the question is do they follow up one mistake with more mistakes? So you buy it here, write it down until it finally then reboots later on, but who knows? So it's still speculation, right? But yeah, it's kind of interesting. So they
What about Apple? Does Apple use the same family with Samsung?
well, I mean, I would assume that Apple's testing, or they've gone back and looked at the batteries they've used to make sure they haven't had the defective whatever. But hey, we might be in for a real, interesting couple of weeks. we'll see, I suppose. But
The iPhones use Samsung made batteries.
Yeah, but it might not be the same battery, or it wasn't from the same batch of the defective ones or something like that. Who knows? Who knows? Um, you know, Apple benefits from now knowing what the batch of defective batteries are before they put it in customers' hands, so they can give it back. But my understanding is it actually wasn't the battery. It was something with how their charging mechanism worked with the battery. Because they're trying to get it approved, the replacement models. Because like right now, if you take your phone in, your Galaxy 7 to get replaced, you don't get a Galaxy 7 back. They give you a temporary Samsung something, another high-end Samsung to hold you over while they're waiting for the FCC approval or whatever for the new fixed Galaxy 7.
I was also looking, it was happening more in like if you just use the charge that came with it plugged into the wall, it was not an issue, but it was when you plug it in like a power strip that had a lot of stuff on it.
Okay.
Like cars, stuff that's not the norm.
It was too temperamental about the exact voltage or something like that.
Charging your phone in the car kind of anyways because the voltage isn't really.
Well, it shouldn't be in general because electronics should have resistors and they should have various components in there that smooth out the flow of energy to the actual component. If you provide a lot of energy, it buffers just like Netflix buffers. So you buffer energy inside of an accumulator, and then ultimately that flows out at a constant rate into the battery. So that's how we control it today, where historically it was more of an iffy thing. So I would say in general it's not really a problem.
Now you have the Galaxy Note 7, you can save for collection, then later you can sell back on the eBay. Then you can write the title of my phone know how to explode.
It knows how to explode.
Yeah,
It becomes a weapon. But I think only 25 of them have actually done something like that's been reported. But that's 25 too many when you have people getting sent to the hospital over it. So I don't think anybody's died from it yet. But I think there was like a 6-year-old kid who had pretty bad burns. So yeah, that's bad news. But in any case, their solution to their problem, they didn't test it enough. And so we can take that real world scenario today and apply it to our world as programmers. And so something you'll learn and you learn about in 150 is what percentage of software applications have bugs. So 99.999% or something like that. They all have bugs in them. Where do those bugs come from? Is it always something we introduced? So if we write a simple hello world program in Java, is that program bug-free if it prints hello world to the screen? Short answer is maybe, but if we didn't introduce bugs, if we wrote correct Java, and because there's not a whole lot of logic in a hello world program, where would those bugs come from? Oh, go ahead.
It was a problem with the Java language itself.
Okay, possibly a bug in the language itself. So the people who made Java, there's the parser for Java. Something under very specific circumstance doesn't quite work the way it's supposed to work. Okay, or possibly the Java compiler, the guy that translates that Java syntax into something else. Maybe it introduces under, again, certain conditions an issue. Could be the Java virtual machine, its interpretation of Java bytecode. Maybe it does something that's, it has to go back and get fixed at a later date, something like that. There's all sorts of levels between us writing that high-level Java syntax and what it actually runs on the CPU. And that, don't let the CPU off the hook. Is it possible for our processors to have bugs in them? They were made by humans. They're imperfect, right? Now, the hope is that Intel architecture has been around for a while and it's been kind of stress tested. So our experience has been that typically the bug isn't in the processor. It's at a higher level. But historically, we've had bugs in processors where they've had to put out revisions or something like that. But we've kind of weeded out the issues at this point. But that doesn't mean that an issue we haven't run into isn't found. Maybe just these 4 instructions in a row just have never been called together, and at some point when they do, we find out that, oops, that's not the way it was supposed to work, something like that. Now, by its very nature, and this would be more of a conversation for the organization class, processors are likely harder to introduce bugs into. And the reason for that is because every little instruction, every little thing that a CPU knows how to do, does so little that there's not a lot of moving parts. Does that make sense? It's not an algorithm that does this many things. It's something that does this. So it's not that hard to test all the little things that can happen with this guy. Make sense? So a little tiny, tiny little problem. So they're less error prone. They're tedious to create, which is why they're expensive, and it's almost like making medical stuff, right? But they're relatively error-free, I would think, at this point. But there's all sorts of layers in between our Java code that we write and the computer's hardware. All sorts of places, filters, where things could go wrong. Bugs could be introduced. It could even be a sometimes bug, right? Get a little power surge or something hiccups in the software that drives your graphics card, and as it's showing hello world on the screen, something weird happens and only half of it shows up on the screen. Or, so you get weird screen artifacts and stuff like that, and a lot of times you just restart your computer and everything's fine. At that point, it wasn't even your software. If you ran your software 1,000 times, it would work 999 times. Except that one time when the graphics card hiccuped, right? So there's all sorts of variants, all sorts of levels in there that we have to deal with. And this actually becomes very interesting to kind of another newer technology that we're dealing with in the world today, and that's self-driving cars, right? So this is similar to the discussion we were having about HTML and stuff like that. So how many of you would get a self-driving car? Think it's a cool idea? 1.5 people. Skeptics. Yeah, I would get one in a heartbeat. Well, think about how, let's fast forward, let's say 10 years. And let's say we've perfected it. Ish, whatever. It's as safe as it's going to get. Won't that change the travel industry? Like, how many of you would drive from here to, let's say, Florida? It's like a 20-hour drive. You go to South Florida. If you basically got in bed at night in the car, slept for 8 hours, woke up, stopped for breakfast or whatever, got back in the car, watched a movie, you're just sitting there, right? And if you're going with 3 or 4 or 5 people, that's going to cost you way less than it'll cost to fly. Make sense? Wouldn't that be interesting to be able to do something like that? Nobody wants to drive for 20 hours straight, but if I'm going to be sleeping for half of that, I'm going to watch some movies, I'll play some video games. We got wireless internet with our cell phones, so who cares, right? If you fly someplace, you're basically right off the whole day for travel anyways, right? Even if it's a 2 or 3 hour flight, by the time you get up early, get to the airport early, and get your luggage, and get your rental car, and all that stuff, the day is shot. It's something along those lines. So it'd be interesting, but certainly right now, there's some issues with the self-driving cars, right? With the software that's in those self-driving cars. Does that mean the software is buggy? What do you suspect is the current problem with, maybe let's say, what do you suspect is one of the biggest problems currently with self-driving cars? Why are we having issues getting those right?
You mean the physical problem or software problem?
Either.
Physical problem, if you self-driving car, it's going to be got hit by other people.
Okay, tell me more about that.
Like if you drive on a corner, so some people are going to hit you, but normally if you...
But people.
Yeah, but the people.
People are going to hit you. Or you might hit people.
No, people are going to hit you.
Could go the other way. Why is that? So my suggestion would be that the weakness in self-driving cars, the reason that's a hard problem to solve, is people. Go ahead.
I was just say that, yeah, like the car's going down the road and it's gonna turn right. It's not gonna by itself decide I want to swerve off to the left, swerve off to the right. Like it's gonna go that way, but there could be a person right-hand lane that's texting, hits on the left.
Yeah, humans. So interestingly, then, so let's kind of connect this to more of a God thing. Does that mean we're buggy? Are we created to be buggy? Certainly, we're unpredictable, right? Okay, certainly, we're unpredictable. We're so complex the way we work, and like you said, we might be texting. We might just zone out. I mean, you don't even have to be, I mean, how many of you have been driving and I'll be listening to my audiobook or something. I listen to audiobooks in the car. I don't listen to music. So I'm not texting or anything. I mean, I'm not going to say I've never texted while driving, but I try not to do that. That's a policy of mine that I've tried to get better at. But I listen to my audiobook all the time, and I assume many of you listen to music, right? Okay. How many of you have been going someplace and completely zone out while you're driving and you just miss your exit or you go to a different place? Okay. More often than you should, right? Okay. So often I'll come out of Concordia and turn the wrong way because the whole summer if I came to the office, when I left here, I would usually be on my way to a golf course. So I'd go that way instead of home, even if it's at night. That's when there's a will, there's a way, I suppose. So we're unpredictable even to ourselves. Okay? That doesn't mean we're buggy. It means we're complex, right? And that's the problem with these self-driving cars today. They're trying to exist inside of a world with unpredictable unpredictable critters, right? How does that car know that at the last moment this human being is not just going to swerve the road because there's a bee in the car, right? Because if that happens, if there's a bee in the car, we go crazy, right? Stuff happens. So the punchline is when self-driving cars become the safest, it's probably going to be when all cars are self-driving, so they can all rely on each other. Okay, but now you have that group of people who really enjoy driving. So I'm not a car enthusiast, but I'm guessing we probably have a couple in here. Who's into cars in here? Okay. I assume you wouldn't be a huge fan of a world where you didn't get to drive a car. Yeah. So sometimes it's convenient, right? Sometimes it's cool. Hey, I'll take a nap on the way to work, something like that. But you enjoy the idea of riding cars. Same thing, I don't understand motorcycles. But there's a huge group of people, just Harley people or whatever, that they go out for rides. It doesn't make any sense to me. But that's something wrong with me in that, not wrong, but clearly there are a lot of people that just aren't nuts. They like motorcycles. It's something they enjoy doing. So now if you take that away from people, what are we going to have in the future? You're going to have roadways that are for human drivers only, right? Is it going to be like a weird world when we have that? We have to start adjusting it's if you're going to go in the interstate, you got to be robotic. Because that is the easiest place. The safest area right now for driving a car automatically is interstate. The least random stuff happens there. So just put all the cars robotic on the interstate. You just dial it in and watch YouTube or something, I suppose.
Who would be liable if you have an accident if you're not driving?
I don't know, Microsoft or Apple or Google, whoever built the software. That's who it's going to be, right? Yeah, Apple's going to come out with their smart car. Google's already working on their smart car. I'm sure Microsoft's going to have their version of the software. And then you're going to have the less, well, I say lesser companies, like a company like Tesla, which is very popular, but obviously a smaller company than Apple. Apple could buy Tesla many, 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 many times and then just shut them down if they wanted to. That's why we have publicly traded companies, and as long as Tesla owns more than 51% of their shares, Apple can't buy them, even if they have enough money to do it, right? Because as long as they don't sell the shares, they can't lose their company. But it's interesting. But yeah, I mean, you'll have liability at the software if you can prove that the software was the problem and not the human being shattering out sensors and stuff like that. So it's an interesting direction that we're going with this type of stuff. But it kind of comes back to this idea of software and what's considered good solutions and that kind of stuff. Go ahead.
It's like the guy that was watching the Harry Potter trilogy on his phone while driving his Tesla, and then somebody hit him from the left.
Mm-hmm.
Sliced him down.
Yeah, I mean, it had nothing to do with the Tesla.
Yeah.
And even if that guy had been driving, the accident likely would have still happened, or could have still happened at the very least. Forget the word likely, we don't know. But, who expected that? Human beings are unpredictable. Okay, but we're not buggy, right? God created us. We're not buggy things. We're complex things. We have free will, and we sometimes make quirky choices. I make a lot of quirky choices. Just ask my wife. It's not good. All right, so we've kind of talked about this idea of problem solving and algorithms from a lot of different angles here. So one thing that I kind of want you to take away from this is when you're writing solutions to problems, when you're solving a problem, there isn't necessarily a right answer. Okay, I constantly want you to take things that you're struggling with when you're programming and take it back to real life and think about how do you solve problems in real life. There isn't one correct way to make a peanut butter and jelly. There's certainly a wrong way, which is the strip of peanut butter thing. That's just weird. But there isn't a single correct way of making a peanut butter and jelly. Lots and lots of ways we could accomplish the same or a very similar outcome. Okay? So kind of have that in mind when you're solving a problem, because what ends up happening with beginning programmers is you immediately want to jump to the Google, right? And find the answer to your homework. All right. Well, when everybody does that, then I get the same solution turned in by a bunch of people, and it's pretty clear to see it wasn't one of my students' solutions. Right? You can tell that it's either an old way of thinking when you just copy something off of Google, because a lot of times you have some older stuff on there. But look for your solution to the problem, because you'll become better at solving the problem over time. This goes right back to us comparing programming to a sport. Those of you who play soccer in here and things like that, or pick any sport. Early in your career as a soccer player, let's say, you might figure out how to kick a certain kick that kind of hooks around and comes in. And that might be a pretty good solution to that problem. But as you become a better soccer player and you come up with some new skills or you become more fit, things like that, you might solve that same problem in your eyes more efficiently, but at least differently. But the ultimate solution might give the same result, but maybe it'll be a more consistent result, something like that. Maybe you accidentally kick an awesome curveball early in your career, kind of by accident. Moon's aligned, and in golf terms, somebody just happens to hit a drive really far and really straight just because the moon's aligned on that swing. 99 out of 100 times they're shanking it or hitting it left or hitting it right. It's one time everything just lined up and it went straight. Over time, you learn new techniques and you become more consistent. So instead of 1 out of 100 times, it's 30 out of 100 times you get good ones, things like that. All right, so keep that in mind when you're writing software, because you're not looking for the solution. You're looking for your solution. And it's very, very important that you each find your own solution to the problem, because some of you are going to come up with more complex or more efficient, let's say, solutions early on. It comes more naturally to you, something like that. You take a natural athlete, they might be able to pick up some of these more complex soccer moves, let's say, more quickly, because it comes naturally to them. Whereas somebody who's a less natural athlete, they might have to take smaller baby steps and come up with like little, kind of almost hack ways of pulling off some of the different moves until they become more comfortable with that, and then they can start segueing towards that more complex movement, but they couldn't just skip the middle steps. They had to go through the pattern of getting used to some of the different physical movements. All right, so it's really important that you kind of embrace the path as opposed to focus on the result. And that goes back to why with programming assignments, I want you to fill out that form, because sometimes the result is not going to look anywhere near as impressive as the effort you put into it. Make sense? All right. So we talked about our virtual machine stuff today, and really the point of your paper was this comparison between general purpose virtual machines like VMware, Fusion, which effectively mimic an Intel computer, software RAM, software hard drive, software CPU. They mimic an Intel computer and all of its general purpose power to solve general problems, versus something like the Java virtual machine, which would be a significantly less complex tool, right? Less complex software, because it's very specific on what it does. It maps Java bytecode to assembly language native for that platform. All right, so it's translating from this low-level language to this low-level language, and this computer, this Java virtual machine, is something that only knows how to run Java programs. It acts as a middleman between your Java code and the CPU. Okay? It doesn't know how to do all these other things. Like if you run Windows 7 inside of a virtual machine, you can do pretty much everything that you can do if you ran Windows 7 natively. You can actually do everything you could do, but some things the performance would be way, way worse. Like you wouldn't want to game on a virtual machine. Okay? All right, so now from a book's perspective, we have finished, in terms of your reading, right? The chapter 3. Have I assigned chapter 4 yet? Okay, but not the exercises, right? So you did these. So you saw the examples, but not the stuff here. So let's look from an algorithm perspective then. So let's look at this drawing a right triangle thing. So this is kind of in the loops, and it kind of shows half. Well, the right triangle is that. Then that last one is half of an arrow. All right. So they're having you effectively create something that looks like this. So we're doing something how many times? So I'm going to throw the problem in front of you. The problem is I want you to write a program that takes in a character, the character you want to repeat on the screen, because we're doing loops, we're repeating stuff, and I want you to read in the number of lines, because we're creating a right triangle. All right? So triangle height. So this was 5. So that means we're going to have 5 rows. The first row we showed one thing, then 2, then 3, then 4, then 5, so on and so forth. Make sense? All right, so we kept increasing the number of things we would show on the screen as we looped down. So if we break that down into little pieces now, what are the things that we need to be able to accomplish in order to solve this problem? Before we even get to the triangle portion, what do we need to be able to do up here? Go ahead.
That's the user for
Yeah, we need to be able to get crap from the user. Okay, so before we can even apply logic, we need to have some mechanism for the user to give us input. All right, when we think about our Windows programs or something, a lot of times user input comes in the form of double clicks and things like that. Okay, but in our world, until we start getting into GUI stuff with the Android side, we're going to have to rely on some user input in the form of this. Okay, so let's just solve that problem. Just that one little problem to give us a Lego, a little tool that we can use to solve other problems. All right, so I'm going to go ahead and I'm going to open up Eclipse. Now, has everybody in here downloaded Eclipse? That was like one of the early assignment things to say to do. I think this is an older version than you guys have, but whatever. Should look pretty pretty similar. All right, so I'm going to go ahead and I'm going to create a new project. So I'm going to right click down here. I'm going to do new Java project. All right, and we're going to do CSC3, oh no, this is 250, right? Fall 2016. And all this other stuff you could just leave alone. And I'll go ahead and hit finish. All right, so this creates a project for me. And right now inside my source folder, there's nothing there. So I kind of have a effectively a directory for storing stuff, but nothing in it. So I'm going to go ahead and right click on the source folder. I'm going to say new. I'm going to say class. All right, and I'm going to call this guy, I always like calling it driver. Okay, and we'll go ahead and say finish. All right, and I always like starting off with our standard hello world program just to make sure everything is, the virtual machine is compiling correctly and running correctly and all that stuff. So we have our public static void main string array args, and then your system.out. Hello world. All right, so that looks legit enough. Then we hit our nice little play button and we get hello world. All right, now remind me, when I hit that play button, what actually happened behind the scenes? We looked at this last class. We're just such a talkative bunch. This is just really an outgoing group. Somebody else that didn't hasn't said much today. You got something? No, you. Yeah, you've only said a couple of things. He said a bunch of things.
I was about to say, when you press the play button, Java VM compiled the results from the machine language to, let's say, lower language, assembly language that the computer could understand and interpret it out to.
Okay. So step one is that command we looked at last time, javac, the Java compiler, took our Java source code here, our high-level language, and converted it into a low-level language, Java assembly, Java bytecode is what it's actually called, but a low-level language as you mentioned. So that's the first thing that happened. It compiled it. And if we would have had any problems, we would have had a whole bunch of red text in here saying, wrong. You did something wrong. All right, but in this case, we passed the compiling part. Okay, that was step one, what happened when I hit the play button. What happened after that? What was step two? So after I converted the high-level language Java into the low-level language equivalent, Java bytecode, what was the next thing that had to happen? Kind of wrote a paper about this. So all of you forgot to write the paper? So, well, we didn't forget. We just didn't do it. When we were running our program in class last time using the command line interface, we did two steps: to compile it and then run it. How did we run it? Who runs our Java program? Oh, that was a hand. That counts. Who runs our Java program?
Just the virtual machine.
Yeah, the Java virtual machine. Our command for that was Java, right? So if we would compile hello.java, javac hello.java would produce a file called hello.class. Then to run that file, we would say java space hello. Told the Java virtual machine to run that bytecode that was there. And the virtual machine converts between Java bytecode and the native assembly language of that computer, right? So when we hit that play button, what's automatically happening behind the scenes are all those little steps. Okay? It's not a ton of steps, okay? But enough things that we can appreciate what Eclipse is doing for us, right? But it's kind of important that we do know what Eclipse is actually doing for us so we understand the process of running a Java program. All right, so we have our hello world here, and so now we know when we hit this play button, several things are happening automatically for us. Okay, now we want to look at how do I read stuff in from the user. And this used to be much more difficult to do in the early days of Java, and then they introduced a class called Scanner that made life easier for us. All right, so what we're going to do is we're going to create a variable. So remember, we've looked in our, when we were talking about variables, the syntax for variables is type, name equals value. Right, that's the generic syntax for creating a variable. All right, so for instance, int a is equal to 5. That would be an example of creating a variable. Well, we're going to create a variable of type scanner. So I'm going to say scanner input is equal to new scanner, and the constructor for scanner. And we'll talk more about constructors, but well, let me just talk about it at least a little bit. The person who actually builds us our scanner needs a little information from us. Okay, they need some input so they know how we intend to read stuff in. So what this scanner wants to know is it wants to know what input stream will you be reading this in from? Are we reading in from a file? Are we reading in from the keyboard? Are we reading in from the internet? Where are we reading our input from? In this case, we're reading in from the keyboard. That's our standard input. So that's called system.in. Okay, so I'll create my variable called input of type scanner, and I'm building it around the standard input stream called system.in, which is a synonym for your keyboard. And notice here, just in like Microsoft Word, they have scanner underlined here because we need to import one of the libraries. Scanner actually lives inside of a library called java.util. So we can either just write it up here if we want, or we can let Eclipse do the work. We can highlight over this. It says scanner cannot be resolved to a type. 7 quick fixes available. One of them is import scanner from java.util. So we'll go ahead and do that. Now it imports it up here, and now it knows what this guy is. All right. By default, if we write nothing up here, there's one magical import. Import java.what? Anybody remember what that is? Talked about it last semester. It's java.lang. Okay, so import java.lang.star. That gives us the core Java language. Ints and chars and booleans and strings and those guys. Okay, the basic Java language, the smallest footprint that is Java. Okay, so that's kind of hidden from us. So we don't actually have to import that. It wouldn't have hurt anything if we did, but we don't have to do it. So we'll go ahead and import our scanner here. So now I've created a tool. Okay, I went out to Home Depot and I got a walkie-talkie. All right, and now I've built it so that I can ask for some stuff and read that stuff in. All right, so we're going to go ahead and we're going to say, what does the book tell us to do? We want to ask for a character and we want to ask for a triangle height. So we need to output those questions to our user. How do we write something to the screen in Java? Do we already have a Lego in our toolbox for writing stuff to the screen? Yeah. System.out guy, right? Now, I think I mentioned this last class. Your job is not to memorize these things. Okay? So whether you remembered it was system.out.println or just made the connection, oh, it's the system thingy. Okay? That's okay. Because now you know that you have that tool. You can go and look it up, say, oh, this is how I printed out the system thingy. Put it in here. I guarantee once you type that 15 or 20 times, you'll remember it. Important thing with that, though, is limit the number of things you copy and paste. Give yourself the reps of actually typing it. It'll help you learn it. Okay? So we want to output some stuff to the screen, so we'll say system.out.print. Now, what's the difference between print and println? We have 2 versions of that guy. Oh, we actually get hands. Go ahead.
Println prints another line after, so it goes on to the line.
Okay, so println presses enter. Right? We do println, it prints whatever we want to the screen and then hits enter so it kicks it down a line. we kind of want it to maybe look the way they're saying it should look here, where it's going to say enter a character and then kind of wait for our input on that same line. So we'll do a print. All right, so print enter a character.
Both was being fussy about that. Like, it said, what's the output? If you didn't press enter again for the line, it would be like, oh, it's wrong.
Oh, that's okay. It's okay for it to be fussy because then you at least have to process through it. All right, I'm going to go, well, actually, I've told you not to copy, so I won't do it either. I need to practice, right? All right, so what are we doing? We're doing enter triangle height. Enter triangle height. Yeah, so I really did need to practice the Alice stuff from last semester, but I've done Java for a few minutes, so we were okay with this one. All right, so this is going to print out to our user 2 prompts, but we're not actually reading crap in yet, right? Walkie-talkies are still in the box. They're sitting right there. We're not actually reading anything in. So now what I'm going to do is we're going to read in our answer into a couple of variables. So I'm going to say char C is equal to input dot next what do we got here with this guy? Come on. And then we have a next int. Do we have a next char? We just have next line. That's fine. So we'll make this guy a string for right now. There's a next character maybe. Make it a string. String s is equal to input dot next line, like that. So that's going to read in a string from the end user and store it inside of our variable named s. We're kind of assuming they're only going to enter in 1 character, but technically going to enter in more than that. We could actually use input dot next int to do this. In fact, actually, let's do that. That would be a good little quiz question for us. Char C is equal to input dot next int. So this is another thing that Eclipse does for us. Gives us our drop down here. So I'll say next, start typing int, and it gives us our example here where we have an int. So just like that. Okay. Now, highlight over this. So what is, he's saying type mismatch, cannot convert from int to char. Tell me, what are chars again? Bytes were 8-bit signed integer values. Shorts were 16-bit signed integer values. Ints were 32-bit signed integer values. Longs were 64-bit signed integer values. What was a char? Unsigned. What does it mean for it to be unsigned? Just positive. Okay, so we don't need to hold any negative numbers. Okay, so it's unsigned. But what does it hold? Yeah, 16-bit, you're right with that. Less important in this argument, but you're right. It is 16-bit. It holds a number, right? It's a 16-bit unsigned integer. So is reading in an int here okay? Yeah, that's what. It's an int. Even though we see it with our eyes as a character, the computer stores it as an int. But I'm trying to store it as a character. So in order to do that, I need to typecast it. So I'll put a little char in front of it there. This says, treat this integer as a char and store it inside of this variable. Okay, so this guy right here, open parenthesis, type, closing parenthesis, is called typecasting. Okay, we're converting it into the type that we want. Now, an important aspect with that, though, is make sure when you're converting something, you're converting it in a way that is convertible. Okay, so don't try to convert a Boolean into an ice cream cone. Okay, not compatible. Make sense? All right, so that'll get us our first character. Then we'll say int, let's call this rows, is equal to input dot next int. And then just to prove that we got those two things, we'll say system.out.println C, system.out.println rows. Okay, so we're going to prompt the user, enter a character. We'll then read that character as an integer, convert it to a char, store it inside of character C, then enter the height, read it as an int, store it inside of an int, and then we're just going to spit both of those out, proving that our walkie-talkie is working, that we were able to retrieve information from our user. All right, so I'll go ahead and hit play here, enter a character. I'll go ahead and put in, I'll match whatever the book did, but just put in some character, press enter, ruh-roh. Oh, it didn't like me converting that. So it read that in, int did not read that in as I would have had to give it the integer equivalent of that. All right, we'll go back to the other plan then. I could make that work, but I'd have to go and look up the Unicode version of the so here, good enough. So enter a character, we'll do our that guy, enter a height, we'll do that guy, and there's our two things. Okay, proving that we read them in and now we can use them. Make sense? All right, so for your homework assignment, two things. Do 4.12 and 4.13. They're very similar to each other. 4.12 is going to be kind of a simple warm-up loop exercise. Now you know how to read stuff, and the book covers this as well. Here, they're getting char at 0. So they're hoping that you only enter something that's one long. And then the last one is to draw half of an arrow. So it's a little bit more complex of a thing here. All right, so you're going to have to put some conditional stuff in there. Make sense? All right, so homework assignment is do both of those things. Do them you can use the tool they have here for writing it if you want, but what I want you to ultimately turn in is the Java code from either here or Eclipse. I would encourage you maybe to use Eclipse so you get used to the tool, but doesn't matter either one, but paste your code into the assignment box along with your self-evaluation. Make sense? All right. No submitting .java files because Blackboard can't handle them. Okay, so if you're going to submit a document, submit it as a .text file or something like that. I will see everybody on Thursday, and don't forget about Bible study if you're interested.